Welcome to this companion video for the KLIKsophone. This video is going to help you understand how this instrument works, specifically how to calibrate and play it, and some of the different options that we can choose between on the instrument. We'll also get into some different failure modes, so things that might go wrong with the instrument, what problems that might cause, and what we can do to fix or avoid those problems. This is not a tutorial on how to make either one of these. That's in a separate video, and I'll put a link to that in the description. So whether you made the KLIKsophone using the Kontinuum Lab instrument kit, or maybe you downloaded the code from GitHub and sourced the components yourself, or maybe you even bought one of these from me over at kontinuumlab.com, and now you're wondering what to do with it. This is the video for you. Let's get into it. First, we'll calibrate. I'm going to use this model for demonstration purposes rather than this one, simply because this one has all of the different options like pitchbend and the extra keys, and so I can show you everything all at once. The calibration routine is the same as on all of the KLIK instruments. First, you press the calibration button. The LED on the microcontroller will turn on and off again, and now you're ready to calibrate. Next, hold down the calibration button while activating all the sensors. That means all the keys, of course, including the octave keys on the back and the extra keys if you have those on your KLIKsophone, but also the breath sensor and the pitchbend sensors. Keep in mind that all of the keys are interpreted as binary signals, meaning that when you calibrate them, you're really just setting a threshold point which will define how much you need to touch each one when you're playing to activate it. The breath sensor and the pitchbend sensors are different in that calibrating those will set a useful range, which will have a huge influence on how they respond when you're playing. You will want to play around with this to explore your own preferences. Once you have a calibration you like, then you can save it to memory by pressing the calibration button 3 times in quick succession. The LED on the teensy will blink 3 times to confirm that the calibration has been saved. If you don't do this, then the calibration data will be lost when you disconnect the instrument. So now we are calibrated and ready to play. The breath sensor is pretty self-explanatory in that you blow into it to make sound. Depending on what breath sensor design you have on your KLIKsophone, how well it's put together, and of course the calibration, it might be more or less sensitive and responsive. The pitchbend mouthpiece with the internal breath sensor has a pretty good range of dynamics. If everything is set up just right, you should be able to play very softly and very loud. And articulate like this. And of course, this mouthpiece has the added magic of applying pitchbend with your mouth. By tilting up the instrument, you contact the top pitchbend sensor with more lip surface, and that translates to pitching the note up. Tilting down does the opposite. The bottle top mouthpiece, however, has its own strength, which is extreme sensitivity and responsiveness. If you take care in the membrane setup and calibration, then this mouthpiece responds even to the softest of input. And it will even respond to trilling or flutter tonguing, which is not something you get out of most breath sensors. The keys on the KLIKsophone are set up to work similarly to those of a saxophone, hence the name. The default tuning of the KLIKsophone is what we call concert tuning, unlike acoustic saxophones which normally tune in B flat or E flat. So the C sharp that you play on this instrument is the same as the C sharp on a piano. Using the 3 octave keys on the back of the KLIKsophone, we can play that same note across 6 octaves. And now we're ready to have a look at how to play all of the other notes. Just like on all woodwind instruments, the notes on the KLIKsophone are produced using a combination of pressed keys. And like I mentioned, the combinations on here are similar to those of a saxophone. The KLIKsophone has a couple of handy features which were adapted from the acoustic saxophone. First, the middle B flat can be played with two different fingerings. And even more importantly, the octaves have a lot of overlap. So the range from B flat to D can be played at both extremes of each octave. This gives a lot of freedom to play lines in different ways depending on the context or your personal preference. And when you combine this feature with the octave keys, the KLIKsophone ends up with a full 6 octaves plus a major third of range. The extra keys function independently from the rest of the interface on the KLIKsophone. This prototype has 6 side keys, but later versions only have 4 of them, and the current code only has support for 4. Unlike the rest of the keys, these have individual velocity-based outputs. Okay, now let's get into the different options. Just like all of the other KLIK instruments, you can change the MIDI output from channel 1 to channel 2 by inserting a jumper in option pin 2 on the breakout board. The pitchbend sensors are optional, and if you want to include them on your KLIKsophone, then they need to be activated by inserting a jumper in option pin 1. The same goes for the side keys, which are activated by inserting a jumper on option pin 0. These are the notes that are output by the side keys. The default output for the side keys goes to channel 2, but if you change the output of the rest of the KLIKsophone to channel 2, then these ones automatically move to channel 3. The default output from the breath sensor is continuous controller number 2, but it can be changed to CC number 7 by inserting a jumper into the KLIK's analog pin 9. CC number 7 is channel volume, and it will give a very different result from CC number 2, which is the official MIDI breath controller signal. Finally, let's talk about some of the problems that might occur with this instrument. Now, these are mostly the same as what I've mentioned in the other KLIK companion videos, and they have to do with sensor construction and setup. So I hope you'll forgive me for repeating myself here. First of all, the KLIKsophone has a bunch of capacitive sensors. The main keys, the side keys, and the pitchbend sensors all fall into this category. These sensors can be sensitive to some kind of noise. For example, the kind of noise that comes from a bad ground connection or entirely ungrounded electronics. Check this out. If I'm playing the KLIKsophone, and then I touch this camera, which has a famously noisy power supply, this is what happens. The same thing can happen if you're connecting to a software synth and the computer that runs that is connected through a bad ground connection. Another typical problem with capacitive sensors is crosstalk. If you connect these sensors with really long cables, for example, then those cables essentially become part of the sensors and they can start to inadvertently sense each other. This is most likely to be a problem if you squeeze a lot of cables into a really tight space. The KLIK calibration routine is designed to take some crosstalk and noise into account. And as you can see here, there is quite a lot of leeway. Even the mess inside this one works quite well. The breath sensor is an analog sensor, and so it's not really susceptible to the same kinds of problems as the capacitive sensors. What you do need to keep an eye on though is the membrane. If the membrane is too loose, so it's able to flop around or otherwise move in relation to the sensor module, then that will be read by the sensor as if it were a legitimate activation. The same goes for a loose sensor module. This might result in a constant or intermittent sound from the instrument, even when you're not blowing in it. To fix this, just make sure nothing is able to move around. Tense the membrane if you have to, but not so much that you have to blow really hard to activate it. If the breath sensor only produces noise or no output at all, then you probably connected the 3 cables the wrong way around or in the wrong order. Make sure that ground goes to ground and so on, and you should be fine. And that's it for this companion video. I hope you found it useful and that it helped you understand the potential and possibilities of the KLIKsophone. If you're interested in buying one of the kits for yourself or for a geeky friend or family member, then you can do that over at kontinuumlab.com, where I sell both the complete kit as well as various types of Klik instruments, including an updated version of the KLIKsophone that I played in this video. The complete kit comes with all of the necessary sensor materials and electronics to make this instrument as well as a bunch more. And all of those instruments come pre-programmed onto the microcontroller inside the kit, so even complete beginners can get started making cool MIDI instruments with zero coding and simple materials and techniques. And of course you can check out the build video for the KLIKsophone as well as all the other Klik instruments from the links in the description. Take care until next time, and I'll see you in the kontinuum.